In this podcast, we are going to see about racemization and what a racemic mixture is. The term racemic comes from the Latin word racemus. Racemus means a bunch of grapes. The name comes from the first mixture to be recognized by Louis Pasteur. He identified the presence of two types of isomers in racemic acid. Racemic acid is nothing but tartaric acid. When Louis Pasteur identified the presence of both the acids in the same mixture in equal proportion, he named it as a racemic mixture. This is where the racemic meaning is derived from. Both the compounds they were similar in chemical structure. The only difference is the presence of one or two functional groups in two different orientations. Pasteur found that if a solution of D-tartaric acid is heated for some time at 165 degrees Celsius, it loses its optical activity, forming a racemic mixture and meso acid. This is due to the fact that tartaric acid having two asymmetric carbon atoms may undergo inversion of H and OH only about one carbon atom or both, yielding meso or racemic form respectively. Thus, we can say that the conversion of a D or L isomer into its racemic mixture as racemization. Now, let us see the difference between racemization and the word resolution. So, what is racemization? Racemization is the process when the enantiomer is converted into racemic modification, whereas resolution is the process when a racemic modification is separated into its constituent enantiomers. Racemization and resolution, they are complementary to each other. So racemization is a process when the enantiomer is converted into racemic modification, and resolution is a process when the racemic modification is separated into its constituent enantiomers. Racemization is a thermodynamically favorable process, and it proceeds spontaneously if a convenient pathway is available for the interconversion of the enantiomers. We can say it is a reversible process because any mechanism of racemization must operate from either of the enantiomers. If a molecule contains more than one chiral center and configuration inversion takes place at one center, then the product formed is a diastereomer, that is an epimer, and the process is otherwise called as epimerization. Due to the free energy difference, the two epimers they exist in unequal amounts in equilibrium. And how do we monitor this racemization? It is generally monitored by observing the gradual zeroing of the optical rotation. And also carbon 13 NMR spectroscopy also gives a good probe for monitoring epimerization of both optically active and inactive stereoisomers. And this rate of racemization, it depends on the molecule and also factors like pH, temperature, etc. And in the case of a racemic mixture, as we have already seen, they contain equal quantities of equal amounts of enantiomers. That is, the enantiomers exist in 50:50 population, and it is a reversible process. Now, let us see about the mechanism of racemization. The mechanism of racemization may involve carbanions, may involve carbonium ions or carbocations. The mechanism also involves free radicals and also involves stable symmetrical intermediates through rotation around carbon bonds and also configurational change in reactions. Now, an optical isomer, that is a D or L form, may lose its optical activity, yielding the racemic mixture by the application of either heat, light to solution in a solvent, or in the presence of a suitable catalyst. For example, if we consider D-tartaric acid, D-tartaric acid may initially undergo tautomerism, that is, it may form an enol form. Now, the enol form, since it's a reversible reaction, when it comes back to the starting compound, it may yield either D form or L form. That is how we get a racemic mixture. So, how does this take place? The hydrogen atom, which is linked to the D carbon in the D acid, will migrate to the oxygen atom of the carbonyl group, forming an enol form. Now, from the enol form, the hydrogen will shift back to the D carbon, involving opening of the linkage of the double bond. So when this double bond opens, it provides an equal opportunity for the hydrogen atom to attach to the left or to the right. This leads to the formation of one molecule of D acid and one molecule of L acid. In optically active substances which cannot enolize because they have no hydrogen atoms alpha to the carbonyl group do not in general racemize except under conditions which bring about other chemical change as well. To summarize, we can say that racemization is a process in which optically active compounds consisting of a single enantiomer, they are converted into an equal mixture of enantiomers with zero optical activity, that is a racemic mix. And racemic mixture is an optically inactive mixture of equal amounts of enantiomers. Thanks for listening.